In this unit with our similar triangles, we're going to be looking at triangle midsegments. Triangle midsegments have different relationships that allow us to solve problems. But before we look at that, let's take a look at what a triangle midsegment is. So a triangle midsegment is a segment that's connecting the midpoint of two sides of a triangle. So looking at the triangle to the right, I see that D is the midpoint of AB, that's why BD and DA are marked as congruent, and E is the midpoint of BC. So my triangle midsegment in this case would be line DE. It's connecting those midpoints. When we take a look at the triangle midsegment theorem, that says that a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side in half as long. So looking at our diagram above, the two lines that would be parallel are AC and DE. So the third side and then my midsegment are parallel. And looking at the relationship between them, my midsegment DE is going to be half the length of AC. We can also write that as AC is double DE, so 2 times DE. And that's going to be helpful when we start solving for missing pieces. Before we do that, let's take a look at just parallel segments in triangles. So number 1 is asking us to identify all the pairs of parallel segments. If we see we have our three sides of our triangle, and then we also have 3 lines on the inside. That means they drew a midsegment for each side. So when I write out my parallel sides, we're going to have 3 different ones. We're going to start with looking at XY parallel to QS. So XY would be my midsegment, QS would be the side of my triangle. The next relationship that we have is WY is parallel to QR. Again, WY is my midsegment and QR is the original side of the triangle. Last one that we have is that WX is parallel to SR. SR is my original side in my triangle and WX is that midsegment. Number 2, the same thing. They drew all 3 midsegments for our triangle, forming 4 little triangles inside. So when I write out those parallel lines, I'm going to have JL is parallel to GH, JK is parallel to FH, and KL is parallel to GF. So that's going to be helpful to remember when we're looking at different midsegments and trying to find our missing values. So number 3, we are going to find some missing values. They gave us sums to start. So they told me that we have our original triangle, PQR, and we want to find all of these different sides. They told me that PR is 46. Well, if PR is 46, I know that the midsegment LM that's parallel to PR is half of that. So LM is going to be 23. Looking at PQ next, they told me that PQ is 40, MN is going to be that midsegment, so half of 40 means that MN is 20. For QR, I have to use the fact that they told me that LN is 17. LN is my midsegment, so to find the length of my side of my triangle, I'm going to double it in this case. I'm going the opposite direction, so double 17 is 34. Then they're asking me to find the measure of MR. In order to find what MR is, I'm going to use the fact that M is the midpoint of QR. So if M is the midpoint of QR, that cuts QR directly in half. Well, half of QR is 17. Number 4, we're doing that same process. They gave us some different side lengths, and we're going to use that to find the midsegment or the segment of a triangle. So starting with FG, they told me that FG is 9. Well, I can use FG to find ED, and I'm going to double that because FG is my midsegment. So double 9 is 18. Then they told me that GH is 7. I can use GH to find CE by doubling it. So that means that CE is going to be 14. And then they told me that CD is 24. I can use that to find FH. FH is my midsegment, so I'm going to cut CD in half, and that means that FH is 12. The next one is a little bit different. We're asking for the perimeter of CDE. So in order to find the perimeter of CDE, I'm going to have to add up all of my sides. So I need CD, I need DE, and I need CE. Remember that we can always use our midsegment relationships to add up all of our sides. And when we add up our sides, we find that our perimeter is 56. Problem number 5 now, we're going to be solving for x. With this, we have our midsegment is 7x and our side of our triangle is 17x minus 18. So both of them are expressions and we're going to need to set up an equation. With this, it's going to be helpful to remember that our midsegment is half of that side, or we can say that the side is double the midsegment. So I'm going to use that fact to set up my equation, and I'm going to double 7x and set that equal to the triangle side length 17x minus 18. From there, we're just solving our equation. So 2 times 7 is 14, moving x's to one side, and solving for x, we get x equals 6. For 6, we're given two expressions again. So the midsegment one is 6x plus 31, and the side of our triangle is 19x minus 36. Again, I'm going to use the fact that my side is double that midsegment, so I am going to multiply this midsegment by 2. When we do that, make sure you're putting parentheses around the entire expression. You need to multiply the 6x and the 31 by 2. When we do that, we solve and we get all the way down to x equals 14. A couple of more examples to solve for. Number 7, we're going to have to solve for x, but then our final answer, we want the full length of DE. So we're going to have to do one step further. But first, solving for our x, we have 4x plus 1 is that midsegment, and then 11x minus 25 is our side. I'm going to double my midsegment and set that equal to the side of the triangle. And when I do that, I solve and get that x equals 9. To get the full length of DE, I'm going to take x equals 9 and I'm going to plug that into 4x plus 1. So 4 times 9 is 36, plus 1 gives me DE is a length of 37. Number 8, we're finding the length of RT. So again, that same process, solve for x and plug it back in. I'm going to double my midsegment, so double 15x minus 7, and set that equal to the side length of 23x minus 6. When I solve, I get down to x equals 4, and I'm going to plug 4 in for my expression for RT. So RT is 23x minus 6, so I'm going to do 23 times 4 minus 6 to get 86. For number 9, they told me that I have different midsegments and I want to find the perimeter of my full triangle. So in order to do that, we have a couple of different things that we need to do. The first thing that we can do is we can mark KJ and JL using the different midsegments that were given. So MN is 49. If 49 is my midsegment, I'm going to double that to get my side JL is 98. Same thing for KJ. I'm going to use my midsegment NO. They told me NO is 42. That's half of my length, so I'm going to double it to get KJ is 84. The last side that I need to find in order to get my perimeter is side KL. We see that KL is given as an expression, 13x minus 10, and its midsegment, MO, is also given as an expression. So I'm going to need to do what I did for number 7 and number 8. I'm going to set up my equation first, so I'm going to double 6x minus 1 and set that equal to 13x minus 10. When I do that, I find that x equals 8, and I'm going to plug that in for KL, and I get that KL is 94. Once I have all three sides, I can add them up. So I'm going to add 94, 84, and 98 to get a final perimeter of 276. So those were all problems being given a triangle, given our expressions, but we can also deal with midsegments in a coordinate plane. When we do it in a coordinate plane, we're going to be using our midpoint and our distance formula, and also a little bit of our slope formula. So looking at our first example for this, they told me that triangle ABC has these points. So that's what I graphed on the graph to the side here. Then they told me that K is the midpoint of AB and Y is the midpoint of BC. And they asked us to verify two different things. The first is that XY is parallel to AC, and then that XY is in fact half of AC. We're going to start this problem by finding those midpoints, finding what X and Y are. To find X, remember our midpoint formula is adding the two X values and dividing by 2, adding the two Y values and dividing by 2. So I find that the midpoint of AB, which I'm labeling as X, is -1, 1. And same thing with finding our Y. And I find that my midpoint of BC, or Y in this case, is 3, 3. Once we find those midpoints, we can find the distance. So the distance is what's going to help us decide if XY is half of AC. Finding our distance, we're using that distance formula. So remember x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of that entire thing. So I'm going to do it for XY first because that's going to be my midsegment. And then I need to do it for AC. AC is the parallel side to XY, so it should be double XY. When I do that, I get my different decimals, so 4.47 for XY and 8.94 for AC. We can check and see that 4.47 times 2 is in fact the value of AC, so that alone proves that XY is 1/2 of AC. Determining whether XY is parallel to AC, we're going to have to look at our slopes. Remember, if they're parallel, they will have the same slope. Using our slope formula of y2 minus y1 over x2 minus x1, we find that the slope of xy is 1/2. And doing that same thing for AC, we find that that slope is 1/2. Since they're the same, that proves that XY is parallel to AC. We're going to look at one more example in the coordinate plane. So again, they gave us our triangle with our points. They told me that R is the midpoint of DE and S is the midpoint of EF. And same thing, we want to verify that those sides are parallel and that RS is half of DF. We're going to start with finding our midpoint for our sides. So R becomes 3, 5, and S becomes 7, 5. Once I have my midpoint, I need to find the distance formula. So I need to find the distance of RS, which is 4. And then I'm going to find the distance of DF. If it works, then that means that RS should be half of DF. I see that 4 is half of 8, so I can say yes, RS is 1/2 of DF. To prove that the lines are parallel, we're looking at the slope. So the slope of RS and the slope of DF are both 0, so those are horizontal lines. If the slopes are the same, we can say that those lines are in fact parallel. So doing all of this, looking at the midsegment both in the coordinate plane and out of the coordinate plane, we're using the fact that it's half of the side of a triangle, or that the side of a triangle is double our midsegment. So that's looking at triangle midsegments.